Hello everyone. Today we are going to talk about what I think is a pretty simple concept. It's called maintaining balance in an equation. So let's talk about that a little bit. Here we have a very, very simple equation. 3 plus 2 equals 5. I think everybody can tell that 3 fingers plus 2 fingers would be 5 fingers, and that equals 5. That equal sign is a big deal in mathematics. We have to keep the left side equal to the right side. So what could I do here? I could add 7 to this side, and that would be 3 plus 2 is 5, plus 7 is 12. And now it does not equal this side of the equation, so it's imperative that I add 7 to that side as well, so that this remains true. Now, to maintain balance, I could also subtract anything that I want. Let's say 4. It would give me 8 on this side, and the only way to keep the other side of the equation the same would be to do the same thing. So I would subtract 4. That would give me 8 equals 8. Another true statement. Then I might divide by 2. That would give me 4 on the left side of the equation. That does not equal 8, so I would have to divide by 2. My point is, I can add anything to both sides of the equation, and I wind up with a true statement. I can subtract anything from both sides of the equation, and I end up with a true statement. I can divide, as long as I divide both sides by the exact same number, or multiply both sides by the exact same number, I will maintain balance. It will stay equal to each other. And that is really, really important for what we're doing today. Okay, so now let's look at a question like this. Which maintains balance in the equation 0.5x plus 70 equals 90? Or 1/2 x or 5/10 x, however you want to say that. There's our equation, and I need to know which one of these maintains balance. So if you look carefully, you'll notice this says 0.5x plus 70. That is true in every single one of these choices. My 90 on the other side of the equal sign is also there for all 4 of my choices. So all I have to do is find where they did the exact same thing. Here they added 70 to the left side, but on this side they subtracted 70. There's no way that those still equal each other. Here they subtracted 70 from the left side and added 70 to the right side. No way they balance out. Here they subtracted 1/2 and they subtracted 1/2 or 5/10. They did the exact same thing to both sides of the equation, and that is our answer. Here they subtracted 1/2 and here they added 1/2. No good. So that's really all they're asking. Maintaining balance just simply means that they do the exact same thing to both sides of the equation. Now, in this particular problem, subtracting 0.5, there's no reason to do that. You would never do that to solve this particular problem. The point is that you could, and you would still have the exact same value on the left, the exact same value on the right, and they would equal each other. It would be a true statement. Let's take another, or look at another one. Here's 2x minus 20 on the left. Same, they've got that on all 4 of these. They've got the 120 over here. And all I have to do is find where they did the exact same thing. Here's adding 2, subtracting 2. Here's subtracting 20, adding 20. No. Adding 20, subtracting 20. No. Those do not maintain balance, but subtracting 2 from the left side of the equation and subtracting 2 from the right side, and I'll have 118 over here, and whatever x value is, I'll have 118 over here. So it maintains balance simply by finding where they do the exact same thing to both sides of the equation. Very simple. Couple more examples. We've got x minus 9 equals 21. So x minus 9, they didn't do anything here. X minus 9, x minus 9, x minus 9. So it's either subtracting 9 or adding 9. We'll see. Looks like they subtracted 9 here and subtracted 9 here. There's my answer already. Here they didn't do anything. Here they subtracted 9, here they added 9, here they added 9, and here they subtracted 9. So, my guess is that most of you can think that is very simple, but it's a really important thing in algebra to keep maintaining balance. Here we would just add 9 to both sides of the equation, and we solve it and have x equals 30. 30 minus 9 equals 21. One more quick example, 7x plus 7. Again, in all of my choices right here, they got that on the left side. And equals 49. We've got the 49 on the right side. All I need to do is find where they did the same thing. Subtract 7, add 7? No. Subtract 7, yes. Add 49, subtract 7x? Nope. Subtract 49, add 7x? Nope. Where they did the exact same thing. And one more, just for fun. Minus 3, minus 3. Minus 3 plus 3, minus 3, nothing. Minus 1 plus 1, no. I think we got it. Nice work.